Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 2721, sum of distances. In this problem, we are given a zero-indexed integer array called nums. We need to create an array, let's call it ARR, where each element ARR at I is the sum of the absolute differences between the index I and all other indices j, where the value at nums j equals the value at nums I. For example, if nums is 1, 3, 1, 1, 2. The ones are at indices 0, 2, and 3. Let's clarify the constraints. The length of the nums array can be up to 100,000. If we use a brute force approach, calculating the distances directly for every matching element, the time complexity would be O of n squared. For n equals 100,000, that is 10 billion operations, which will definitely result in a time limit exceeded error. Therefore, we must find a more optimal approach, ideally O of n time complexity, using hash maps and prefix sums. For our thought process, we can first group all indices that have the same value using a hash map. For each list of indices, instead of comparing every pair, we can maintain a prefix sum. Suppose we are calculating the distance sum for an index at position k in the list. The sum of distances to elements on its left can be calculated by taking k times the current index minus the prefix sum of all previous. Here is the first part of our C++ implementation. We initialize a variable n with the size of nums. We create an unordered map called POS, where the key is the integer value and the value is a vector of its indices. We loop through the array to populate this map. Next, we prepare our answer array of size n, filled with zeros. In the second part, we iterate over each group in our hash map. We calculate the total sum of all indices in this group. Then, we loop through each index in the group while maintaining a running prefix sum called pref. For the current index, we find the sum of distances to its left using the prefix sum, and the sum of distances to its right using the total sum minus the prefix sum. Finally, we add both parts together and assign it to the corresponding position in our answer array. We then return the answer. Finally, let's review the complexity analysis. The time complexity is O of n, where n is the length of the array. This is because we group the elements and process each index exactly once, and our prefix math takes constant time per element. The space complexity is also O of n, because we store all the indices in our hash map, as well as the output array. Thank you for watching.